Okay, let's see if I can get automatic. Where's my? Probably got the wrong game set on. Get rid of that category. That's wrong. Pro. Let's first put just chat to make it correct. Okay, that's updated. Okay. Now let's see. Okay, is programming? I thought programming was in here. Not the game, but the act of programming. I don't see it. I could have sworn they had programming on category. Huh. I don't see it. So it's just chatting, I guess. Great. Um. Okay then. It's just chatting. Wonderful. Now to figure out how to fix. Uh. Where is live on YouTube? I don't know. They've moved everything since I last did this. It's supposedly on my channel right now, but I don't know if it is. Um, create? Go live, maybe? Yeah, shut up. Okay, here it is. It's here. It's public. Yep, yep, yep. And yeah, it's connected. So, let's see if I can. Oh, wow. Okay, my voice is very clear. Great. Fantastic. Wonderful. It probably looks like ass, though. Um, so this is all going to be very rinky-dink and scatter-shot, like broken and fun stuff. So let's see if messages work. I haven't done this in so long. Okay, that showed up there. Showed up there. Wow. Okay, so everything still kind of works. Fantastic. Okay, so we're just gonna be really frickin' boring and looking at a bunch of code and shit because that's what we. I've already filtered this to Bluetooth hit transaction. So obviously this one here is misidentified as a keyboard. That's annoying because when that happens, I don't know how to make Wireshark stop doing that. Like the report ID is the protocol code is not keyboard. Protocol code should be unknown, but it's keyboard because reasons. And I don't know how you stop that because I am not a Wireshark expert. And as it is, this is a cap file I got from a friend, we'll say. And it's missing random packets, and it's only got like 58 seconds of data because the poor Bluetooth dongle they were using as a middleman in the middle attack basically couldn't handle it. So who knows? I already figured out how to turn on the microphone in the DualSense controller using, but I figured maybe I'll take another crack at it since I currently hate everything. Discord's being assholes. So, let's see. We're going to export all of the packet dissections as C arrays so I can actually work with them clean. That's going to be fun to though. Okay. So we are going to call this test all hid.c. Okay. And I'm going to have to Let's see, how do I do this? I guess I'll add Notepad++ to the screen. Start working with. That'll be fun. As soon as Explorer stops being frozen. I have fiber internet. I called it test. There it is. Test all HID C. Okay. Let's move this to a new window. Move to new instance. Perfect. Okay. We will add this instance to add go capture, not start visible. Otherwise, it just picks a random window because it's smart. Okay. So we've got our text, our text here that we have. So of course, it's not very usable right now in this form. Hello, Hyperfighter. As you can tell, I'm slowly going insane. They still haven't responded to my ticket, still. So I've got 30 days before they delete me. So I'm reverse engineering because that's a smart use of my time. And of course, immediately Notepad++ is frozen, so that's beautiful. Okay, so this code is very not useful, as we can see looking at it. So I need to change this into a format which I can more easily work with in Notepad. So the first thing we're going to do is get rid of these comments because they're just in the way. So we know that the comment structure is a certain way. Oh my God, it's so angry at me. How long is this file? Oh, it's really freaking long. Okay, we're going to be trying to fix that. Of course, it doesn't capture the regex window, does it? Oh, that's not very nice. What if I use bitflit? Does that work? No. And an up capture. Uh, so yeah, you can't see the dialog box unless I capture it separately. That's a dick. Okay. So the DualSense is the PlayStation 5 controller. And I am the person who figured out all of the trigger effect factory functions. So I'm the one who figured out how to make all the trigger effects and stuff happen correctly on PC without using Sony's driver information. I bet you didn't know I did that. Uh, I'm that guy. Um, and I made the code freely available under MIT, so people can make any changes to the factory functions. I don't know if anything's using them aside from DualSense X. I know DualSense X uses them, and I actually got development access to DualSense X. And then before I had a chance to get involved beyond basic stuff, Discord banned me. And it's on Discord where all that communication is. That's where my communication is to the guy who writes the drivers. That's where my communication is to the guy who the multiple people now involved in DualSense X. That's where my communication with the other controller people, with the handicapped disabled people, where I'm trying to help get software working for controller stuff. You know, the Discord decided that they're gonna ban me, controller guy, for bullshit reasons that I happen to be. I think it's that I was in the wrong server at the wrong time. I don't actually know because they don't tell you that. You have to figure that out on your own. They just blame you for what the server supposedly did. So according to Discord, I'm a dehumanizer. I mean, I might talk to people like they're computers, but I'm not a dehumanizer. I don't. I think in the list of possible causes for my ban was denying the Holocaust, which is hilarious. Yes, we're going to say that John Klein denied the Holocaust. No, obviously I didn't. That's ridiculous. Um, but Discord hasn't responded for 8 days, so I'm getting very, very angry. Um, and as you can see, I haven't poked my ticket because poking your ticket pushes it down the queue. You guys really should. Anyway, I digress. The DualSense is the PlayStation 5 controller. It has really fancy triggers on it that when you pull them, they actually will vibrate or have resistance on them, or even there's a single shot gun mode where when you pull it, it actually has a spot of high resistance, and then when you pull it past that, it suddenly releases, jumps past that, and the controller actually has a separate state for not on stop, resting against stop, and past stop that resets when you release it all the way. So it's really good for like semi-automatic rifles. It feels correct. I got all that working. But the PlayStation 5 controller also has audio-based haptics in it. Instead of vibration motors, it has LRA, linear resonant actuators. They're these big heavy weights that vibrate back and forth, and they're driven by sound. And there's also a speaker on it and a microphone on it, and there's also a headphone jack microphone. I already figured out how to make the controller start sending audio over Bluetooth to the computer months ago, and it took me about a month to figure out how to decode the audio. I got that working. I can now. I am the only person on the planet right now that has a PlayStation 5 controller sending microphone audio to a PC over wireless and have it working. Trying to figure out how to make the audio come out of the or how to make the audio coming from the computer go to the controller wirelessly, and that's very difficult. Especially since I don't have a PS5. So even if I was to collect the correct equipment, I don't have the console. Also, Bluetooth logging conventionally costs tens or maybe even hundreds of thousands of dollars for the equipment for it. I came up with a jacked up way that'll work in this one situation, and actually, someone kind of implemented that method, but my method is based on this person actually figured it out first. They used the PlayStation 5 controller pairs with the console over USB, which means if you make a USB man in the middle, you can mess with that pairing. So someone took a Bluetooth dongle and made it so that when the controller thought it was pairing to the console and vice versa, both the console and the controller instead paired to the dongle. Then a piece of software running on the computer relayed all the messages back through again to the other target. And they generated a log, but they only got like 59 seconds, 57 seconds or so of data, and a lot is missing. So that's the data that I have here. Now, unfortunately, that data is theoretically not that useful. It theoretically is not going to help us, but it's worth a try because I did find the command that lets you turn on the microphone, and since I found that, I think it's safe to say that what I want does exist that what I want might exist in this log. The question is, did the PlayStation 5 start sending audio of any kind to the PS5 controller before the 1 minute was out? That's the question. So let me add a window capture to show what I'm doing. That's good. So I need to convert this information that I have into a form that I can process. So right now it's very ugly. And I'm trying to make this match the comment, which it does. Okay. So let's make it also match the space before the comment and the new line. Okay. And let us replace it with a space. So now if I replace this comment, there we are. And that one's a little superfluous, but it works. So this is what I'm doing. I'm making all the data prettier. So replace all. And now we wait while it chews through a ridiculous amount of information. I have a prior analysis of this data that I did where I figured out like this weird sub-packet carrier structure, which I'm going to be referencing cleaning this up, but this has more, I exported more of the packets this time into this format so I can try to figure it out. As said, it's going to be a doozy. Like right now, as you can, actually, you can't see the title bar of the program. Oh, that's interesting. The title bar of the replace dialog currently says replace, not responding. It will get there. While it's busy, look at the original capture here. This is the original capture log that I got from the person. You can see here we have the controller and the host items. Let's see. Controller and host backwards. That's fun. But that's because this is the wireless controller is sending messages to this Rasper, whatever that is, and then the Rasper here is sending messages to CloudNet, which is the PlayStation 5. So as you can see, this thing is sitting in between the PlayStation 5 controller and the PlayStation 5 console. And I unfortunately can't talk to the person who gave me this log because I only have them on Discord. I swear, they want to make it so that so yeah, this is all that data, and I realized that if I apply this filter, it filters to only things with data. You might see the word keyboard here. These are not keyboard packets. They are packets that happen to be using the report ID 01, which is normally for a keyboard. It's not, in this case, a keyboard, but it decided it was, and I don't know how to make Wireshark stop doing that. That's part of the reason why I'm dumping it. You might not know, but I also highly documented the controller interface. Okay, the program's. Let me just come here, get this. Add window, no capture, or invisible because I'm not insane. Capture that. Oh, actually, I just realized I can turn the title bar on this. No, I can't. Anyway, this here is documentation that I wrote for the controller's interface. So I actually sat there and wrote out the entire interface structure for the PlayStation 5 controller and made it publicly available on this page. Here's the report list and what I know, and some of them I don't know what they. Here it is in Bluetooth mode. Here's actually I can say something quite weird about it. Let's go to the PlayStation 4 controller page I wrote. Okay, so the PlayStation 4 controller. Um, yeah, that's the debug interface that I found. Okay, so this is the USB interface. Don't care about that. Bluetooth. On the PlayStation 4 controller on Bluetooth has all of these possible reports here. Hex 11 through hex 19 are all inputs containing the controller's buttons or audio data. Most people don't even know this. They only know about this one right here, hex 11, when it has controller state. And here is hex 11 going outbound for like setting the controller rumble and the LED colors and stuff. But it's actually 11 through 19 because it can contain audio. And the way it works, let's see here. No, that's Bluetooth. Okay, the way it works is that the packet contains the report ID, some information on the polling rate and stuff, but it also contains a flag to enable for if the packet contains microphone or controller data. And most people ignore all this. I had to actually submit a fix to SDL to make Steam stop going insane when I turned on the PS4 controller's microphone because sometimes packets came in that it thought were game controller inputs and they were actually just audio. So using this, you can double check there's actually controller data. But yeah, if you look at all these, you'll notice that all these report structures are the same, except for the fact that they're bigger. Each one, this one it's this structure, this precursor structure, and then it's either an audio structure or a state data and audio structure, both of the same length. It's one of these two. I don't know which yet. Well, you don't know which for any given packet unless you check. But that's what a union means, and a union means these both are in the same place. It's a C++ thing. Um, so this audio state data and audio state. Oh, interesting little quirk on report 11 because it's the smallest one. It's either controller state or audio, where all the other ones are controller state and audio or audio. I need to replace this keyboard. Okay, so here we go. The controller state state and audio is just a state packet followed by a state data followed by audio data, where the audio data is 75 bytes less than the entire thing because this state data is 75 bytes normal. I'm sure this is all completely gibberish for you, but you know me explaining programming. But the PlayStation 4 controller uses the SBC audio codec, and it basically stuffs it into the packets. The SBC codec is a freely available codec, but only if you use it with Bluetooth devices. Um, Now, using the correct way. If you format it correctly, you can make audio come out of the speaker on the PlayStation 4 controller, but you can only do it over Bluetooth. It's not available on USB, which is really dumb because they let you send right and left headphone data out to headphones that are plugged into if you plug a version 2 PlayStation 4 controller into the computer, it shows up as an audio device, and you can actually plug a headset into it and have a single channel microphone and dual channel audio. Except if you switch the controller into a certain mode, the headphones go mono, like one of the speakers cuts off and starts coming out of the speaker instead. From instead of the headphones, it comes out of the speaker on the controller. But for some reason, they didn't let you do that in USB mode. Now, they corrected that error on the PlayStation 5 controller. You can do it on USB mode. So you can actually make the speaker work in USB mode on the PlayStation 5 controller. Interestingly, they also, on the PlayStation 4 controller, when you send one of the audio channels to the speaker, that audio channel gets muted on the pair of headphones. But on the PlayStation 5 controller, your headphones turn mono while the speaker is in use, which is an interesting difference. Now, that whole thing is when it is plugged into USB for the PlayStation 5 controller. I would not be surprised if when the PlayStation 5 controller is in wireless mode, if it has 5 output channels. I expect that it has 4, but I would not be surprised by 5. I mean, it has 2 microphones and it has 2 mic input channels, but they're not the 2 microphones, hilariously. There's something called, I know from some leaked information, a leaked SDK related stuff, pulling strings and stuff out of that the microphone's 2 channels are called chat and ASR. I'm going to guess that ASR means automatic speech recognition because the chat version of the microphone data respects the volume setting and the ASR one ignores the volume setting. So I'm guessing that ASR is not meant for other people to hear it. It's meant for the computer to process it. That's why I say automatic speech recognition. It's a complete guess. And the PlayStation 5 controller, the reason it has 2 microphones is it does cancel, like, it can cancel out sounds on its own. So it knows that if a sound hits the back microphone before it hits the front microphone, that it should try to remove that sound. Theoretically, there's a beam forming toggle in it, but I can't actually haven't got that to do anything, and that's based on leaked information, so I couldn't confirm that. The leaked information is very, very sparse. I had to do a lot of work to turn it into something. Most of what I learned, I actually learned before the PlayStation 5 was even out, because the controller came out first for some reason. Whatever. Um. Oh, the notepad finished. Okay. Well, yeah, I'm bouncing around. Where did my window go that I was showing the control? You'll have to excuse me because I do have 1175 Chrome tabs, and that is a little bit much. Okay. DualShock 4. So yeah, the DualShock 4. The interesting thing about the DualShock 4 that I wanted to say before I go back to the DualSense is that on Bluetooth, it has these 9 reports out and 9 reports in because it needs varying amounts of space to put the audio. The DualSense, however, this controller in wireless mode and Bluetooth mode has 1 report to get the controller state and 9 reports to set the controller state. The only one we ever see used for setting the state is 3.1 right here. So most likely, my assumption is that these involve audio, and my guess is that the being 4 channels at minimum, because of the two for right and left haptic and 2 for the headphones. I say at minimum, it's more at maximum, but you know what I mean. The minimum for the maximum is 4. I'm thinking maybe it's for that much speed, for that much space. But it is weird. Um, yeah. So that's what I noticed, and what I'm trying to ascertain the reason for. And without better captures, this is kind of being black boxed. So this is gonna get really interesting, really, really slowly. um, okay, so the next thing I'm going to do is I'm going to replace this um, sequence here with nothing. Let's see. Match. Yes, it does. Okay. Replace all of them. And that's going to freeze again. So let's go back to. There's a lot of weird functions here. Oh, it actually unfroze pretty quick. Okay. I guess because I got it, I vastly reduced the number of lines. Okay. Next, we need to get rid of this comment. I think it's always going to look the same. We're going to say that bytes might be singular, so it might be byte. We're going to have to escape the parentheses for the regex. And we're going to make this a number. I know there's shortcuts for digit and stuff, but it doesn't like that. Oh, it doesn't like the stars. God damn it. I hate that that's so easy to do that. Okay, good, it's in the hit. So escape this asterisk for that regex. So many keyboard places. Okay, that works. So get rid of all of those. We're making progress here, making this usable. Okay. So now we are going to remove all empty lines. We do that by replacing new line with just one new line. That'll make us be working with a lot less junk. Okay, it's frozen again. Oh, and it's done. Okay, that appears to have worked. Yeah, can't find any more. Let's save again. So now we're getting to the fun parts. We're going to do the beginning of the line followed by any number of spaces, or 1 or 0 or more spaces. Replace that with nothing. Replace all. Okay. And now we are going to get rid of this little chunk here, which is some number of spaces followed by curly brace, parenthesis, and end of line. Yep, that's working. So clear all those. Okay. So now to make our job easier, we're going to make sure every line starts with comma space. And we are going to replace all. Okay. Perfect. And now we are going to replace all. God, I gotta swap my V key. We're gonna replace all comma space OXs with just a space. Actually, no, we're gonna replace them with no spaces at all. This should mash this into hex, basically. And we're getting there. I guess I will do more explaining of. Yeah, I will do more of this. We've got some interesting things here. Like the PlayStation 5 controller actually has a series of 5 lights underneath the touchpad, and those lights are used to indicate the player. And they actually changed it to 3 lights with a light guide that splits them on a certain hardware revision. And you can actually ask the controller which hardware revision it is to know if you have which light configuration you have. Because interestingly, it's 5 lights to say 4 things. So if you look right here, for a way I can make this. Yes. If you look right here, you can see that there is a bit for each light. So 1, 2, 3, 4, 5, and then there's a bit for that makes them fade instead of instantly turning on. And then there's 2 bits that aren't used. So this number here is an 8-bit number, and you can toggle each light individually. So you see you can toggle the first light, the second light, third, fourth, and fifth light. But if there's only 3 lights on it and you try to toggle them, you'll instead see this pattern here. Now, the thing you might notice about this pattern is that, like, I have a space where there's no LED, and I have an X when it's on and a dash when it's off. Pay attention to this section here. These are what the PlayStation 5 actually sends, and what the Sony's official API sends. So it sends a single light on in the middle for player 1, 2 lights on in the middle, on either side of the middle for player 2, then 3 lights for player 3. And if you look, they took very careful placement of these dummy spots that have no lights, because this is a nice and evenly spaced out 3. Not scrunched, it's not reusing anything, it's nice and evenly spread out. And it's true that they could have put the lights here and here instead to do 3, but then look at 4. Because they did this alignment for 3, they can do this alignment for 4. So players 1, 2, 3, and 4 always have the number of lights perfectly evenly spaced. And then if you create like a fictitious player 5, everything flies out the window and it looks like shit. But yeah, that's the PlayStation 5 controller. Depending on which hardware revision you have, there might only be 3 larger lights instead of 5 little ones inside, and they use little light diffuser guides to line them up. The the poor replace is still running. So that's the lights under the thing. There's also the RGB light on the controller. The PlayStation 4 controller used to just be on the front of it. You couldn't really see it when you were playing, and the reason was that if you had the camera, it could identify your controller by the light. And then if you moved your controller around, it had the gyroscope and the accelerometer inside. And the camera seeing the light could also help understand the movements better. They used the same technology for that the PlayStation Move used with the glowing ball. Then the Revision 2 PlayStation 4 controller, the DS4 V2, or Slim or Pro, whatever you want to call it, that one added a little bar on the top of the touchpad that lets the light through so you can see what color your controller is set to. And that's because the colors are for specific players, so it was so you could actually see what player you were by looking at it. And the PlayStation 5 controller, interestingly enough, does not have a light on the back at all. There's no light on the chart on the side where you put the port, because it doesn't get tracked that way at all. Instead, they made it so that the light shines from both sides of the touchpad, the right and left side of it, to tell you what player you are. Now, games have made some interesting use of this. I believe in Metro one of the Metros. I think it's what is it? The third one, with the train and stuff. That Metro, it actually dims or brightens the light on the controller depending on if you're in light or shadow, and thus if you're visible or not to other to enemies. Just a nice little feature. I don't know of anything that really makes use of the mic. Oh, interesting fact: the mute button on the PlayStation 5 controller is just a button, and whether or not it is glowing, not glowing, or has a breathing animation on its amber light is also just a setting. So there's nothing that actually proves your controller is muted when you mute it. I can make the controller light up like with a like the mute button up and still read the microphone. It doesn't actually mute button. So that's kind of funny. But what else do we have? Oh yeah, here's that output thing I mentioned. Um, when it's set to 0, the left and the right headphones are on, but the speaker is off. When it's set to 1, the left channel is sent to both headphone speaker. When it's set to 2, the left is on both and right is on the speaker. And when it's set to 3, it's just the speaker, the right channel. It's very strange. Um, they do weird stuff with the audio too. Oh, good. Notepad is no longer frozen. Okay. So this is the raw data sent. This is the actual data sent to and from the controller. You might notice that we're missing any sort of context of any kind. Also, you can't see it because I'm an idiot. There we go. This is the raw data. Um, it's orange because it still thinks this is a C file, so let's fix that by setting it to um, where is none? Oh, none. Okay, there we go. So we cannot figure out what direction this traffic is going easily. However, it is hid traffic, or it is hid over Bluetooth traffic. So I know a couple things about that. This is report ID 1. So, oh, this is not a good time to have a malfunctioning right button on my keyboard. Shit. I can't count this way. 16. Okay, there it is. Found it. Found what I was looking for. I happen to know a little bit about Bluetooth HID. Ta-da! A1 is the prefix that occurs on all of the HID or all of the report structures for some reason when you're doing HID over Bluetooth. So then the next byte will be the report ID. Let's start labeling stuff. Okay. And let me move some controllers out of the way. I have a lot of them. So we have the ID. And the way that the PlayStation works, the next byte is the sequence number, kind of. Doesn't just do the sequence. Well, actually, it's not always the sequence number. I was wrong. That was a goof. But not wrong for lack of trying. It's because of something retarded. This report ID 1 coming, I believe, in from the controller. I already know what this is. This. Oh, I gotta fix that. Okay. Report ID 1 on Bluetooth is the simplified controller state data. So there is this weird thing where when you first run the PlayStation 5 controller on Bluetooth before anything talks to it, it runs in a kind of simplified stupid mode with very simplistic data. It just has this data structure here after the report ID. So what this is actually doing is it is the LX, then the LY, then the RX, then the RY, of the controller joysticks. If we actually look at this, you're going to see values around 80, because 80 is roughly centered, because PlayStation joysticks go from 0 to 255. Yep, see, left X, left Y, right X, right Y. Then comes the D-pad, which is for nibble. You get the idea. BTN. We'll just say BT. Let's see, 4 bytes followed by 1, 2. Okay. So the D-pad. Oh, by the way, 8 on the D-pad is centered, which is why you see an 8 here. or you might not see an 8. I'm not sure how clear it is. Yeah, it's a bit raw. Um, so we've got the D-pad 8, and then this right here, this 0 actually represents the square, cross, circle, and triangle buttons. And then these two here are the shoulder buttons and the share and the clicks, stick clicks. And then shit gets kind of weird after that because then comes the extra buttons, um, which are a little bit different in their rules. The At least on the PlayStation 4 they are. I don't know about the PS5, but they're the extension buttons. So the pads click and the home button are there. And then there's also a counter here. And then finally there is trigger left and trigger right. Okay. Now the thing about these is that this is the mode you don't want to bother using the controller. It just sucks. It sucks ass. I wish I could freeze this first row. Do that. Can I freeze a row in Notepad? Um, but yeah, this is controller state. So I don't even know if it's worth keeping this here, honestly. I know I expanded it out, but it was just to show it to you. Have to think about it. A3. What is A3? I think that is a feature request. I'm going to confirm that in the original capture. Oh, A3 is indeed a feature. This particular feature is coming from the controller. I think, yeah, it's coming from the controller. I can't really. So this part here will probably tell me that, but whatever. So this is a feature report. So none of this matters. Understanding is. This is the feature report OX20. Feature report OX20 is get controller version data firmware info. So this is just getting the firmware info. Let's just make ourselves a work area where we can put comments by getting stuff. Oh dear, it doesn't like me doing that. Oh no. Um, and I don't think insert was even. So trying to edit 3,993 lines at the same time has some difficulty, I will say. I'm going to do it again though. So this data might be useful, but honestly, I couldn't care that much. I'm just going to get rid of it, but leave a padding there because it'll give me space to okay, maybe it'll just hate me. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do, 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 do. Come on. Do it. Anyway, that packet is going to be to get that information, so we don't really care too much about that. Okay. I think it was here. Yep, here it is. So this is get version. Okay. So these are all set basic controller state. We don't care about that. You can see some more setting the basic controller state here. But you know what I'm going to do? Because we don't care about setting the controller's basic state. We're just going to say go away. That's what we're going to So all that work marking I did was actually pointless, but I don't mind because even though I did it to show you, I'm also refreshing myself on this. So basically, we're going to remove all of these, and at some point they're going to stop on their own. In fact, they did. They stopped here. Not sure why they stopped there. Um, hmm, that's odd. Why did stop? Is there an output I missed? Oh, I just realized all of these things are going to actually be double listed. Oh, that's funny. Um, yeah, a lot of stuff's going to get listed twice because of the way the packet capture worked. Okay, that's fun. Um, it's basically that stops when the controller receives something that tells you that you know what it is, and then the controller stops acting in stupid mode and starts acting in fancy PlayStation mode. Um, but all this information that we had marked here is no longer relevant. But we do have the sequence number. So this first bite here, or first nibble here, this is actually the second nibble of the bite, but this is the sequence number when it's the right kind of packet, that is. So all of these 3-1 packets, this is the sequence number. And as we can see, it's counting up nice and clean. And in the spots where it's screwing up, we see it's actually a different packet type. Oh, that's interesting. I'll make that. Okay. So we're sending out a report to the controller. We are sending report ID 31. We have a sequence number and a 1. Okay, let's see what my notes say this means and see if my notes are correct. Actually, are we sending out or are we receiving? Let's see. Actually, no, we're receiving this. Okay, this is coming in. These are reports coming in. So this is a get state. And the get state packet is saying... Wow, okay. Unknown 1. Oh, wait, now I'm sorry. It's unknown 1 is later. Never mind. I'm blind. I was looking at unknown 1. Where was I looking? I was looking at the unknown 1. Forget it, doesn't matter. I'll just find what I want. So this is report 31. It is a get state report. Input. Ah, here we are. So what this structure is a union of two structures. One is the Bluetooth CRC structure, which is literally just a dummy structure that puts the CRC at the end for and puts it in the right place for you. Funny thing, these are all C and C++ structures. I wrote them all. I work almost exclusively in C#, which does not use any of this. But I thought these structures were just so perfect for detailing information on structure of data that I used them this way for my documentation. So they might have minor errors. Okay, here, this is interesting. I have it written that the binary of the first byte, this binary, I have it written that the first one is if it has hit, if it has hid. Okay, that's all well and good. There's got to be a way to stop Notepad++ from using tabs. It's really annoying. Okay, and I know that this one here has microphone data, interestingly. And I know that this one here, or these two actually, I have no fucking idea what they mean. And then the other three here this is the sequence number. So this is the sequence number, but these bits are has hid, has microphone, and I have no fucking idea. Now I have a note though. I say looks mutually exclusive, possible mic data, which means I discovered that if you set this bit true, which means you set a value of OX01, it's saying that the packet has hid information in it, which means the controller state. You set a value of OX02, which would be 10, it says that it has microphone. If you set a value of OX04, wait, I say 3, I'm sorry, 2. 2 has microphone. If you set a value of OX03, which is 11, not 1, 1 is 01, 2 is 10, and then 3 is 11. It does fuck all nothing. Which means that it looks like these bits are actually all part of a number, just like this number. And this number is saying what is in the packet of information. Now, this is a guess. I have not been able to prove it out, but it appears to be the case. Actually, I might have made another error. Look at this. I actually don't think this is part. I think these might do nothing. I think the ones that have a question mark be nothing. But I know for a fact, according to my notes, if you try to turn, if you will never see mic and controller state at the same time, it just doesn't happen. And I think it's impossible. Now, because these are messages coming from the controller to the console or to the computer, I don't know because I can't force an invalid situation. So what we've got here is we've got the sequence number counting up, and we've got a 1 here. And that 1 means that we're dealing with controller state information, which means this whole sequence here is just the controller state. You're just saying get state. All the way. All of these 1s, all of them are just get state. I'm not very good at. So we know that all of those are just get state packets. They really don't matter. This sequence of bytes here is just talking about like where the joysticks are, where the buttons are, how the motion sensor is going. And the last 4 bytes on the end, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Did I miscount? I did. There's 8. This is the CRC32 of the packet. So the bigger issue is actually that there is a CMAC, an AES CMAC on the packet. That's here? Yeah, I think that's that. That's because the PlayStation 4 had a lot of devices that you would connect the controller to and then like plug it into the system, and those devices like add back buttons or do hacky stuff or cheat and stuff. And that's because they took the incoming signals from the controller, added in some additional or changed some stuff, changed the hash if it was even there, which it wasn't for wired, and sent it to the console, and the console just worked. So your stuff like your little add-ons that you attach to the controller, and you get like recoil compensation or something. That's what that was. So by putting this AES CMAC on here, this information, which I believe part of it involves the secret inside the controller that is used to authenticate the controller is real. I don't know that sure, but I'm pretty sure it does that. that means that both through the obscurity of not knowing how to do this, and even if you figure it out, needing the unique key of the controller or some other, who knows, it might even be some trick where, I mean, the key from the controller is signed by Sony. So when the console gets the controller, the key, it then checks if it's signed by Sony, and then there's some other trick it does to make sure that the controller can also sign things itself. So it's really nasty. That's the DualSense or the DualShock 4 and the DualSense. This CMAC basically prevents you from injecting anything into this report that you wouldn't normally, because you wouldn't know how to generate this part here. Um, wow, you can't see what I'm talking about at all. I'm sorry. This is the hash I was talking about at the end. This is the CMAC I was talking about. You can see this hash, how it is in the same place every time, the CRC32. And then this is the AES CMAC I meant that validates the controller. Actually, it's this. Yeah, I'm sorry. Um, so that prevents you from doing like recoil compensation add-on hacks and stuff. The PC doesn't care, which is nice. So this could be all zeros, and this actually might matter. I think the Sony library actually cares about this, but this it doesn't care about, so that's fine. Um, so yeah, we got joysticks, triggers, buttons, and then here's the motion data. And I think this would be the touch data, possibly, or it might be the jack data, because it also has data on. I think that's the battery byte there. If I was just going to guess by eyeballing it. But yeah, so that's all get state. Now we could translate this, but it's not really worth bothering. Some of it is text, some of it isn't. It's basically identifying the controller's manufacturing date, or rather the firmware date. And for some reason it's here twice. I don't know why. It's a little weird. Um, but okay. So we have more controller state, yada, 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 yada. Boring, boring, boring. Then we have this. A2. That I believe is a write. That's going to be a normal report out from the console to the controller. So it's again 31. And we know from report, let's see, report out. Okay. We know a little bit about the structure here. We know that the first byte is the report ID. Okay. The second byte here of zeros is the data. Huh. Why are you? Oh, okay. No, that's not no. That's still confused. Um, what? This might be important. So these 2 bytes, you know what? I'm going to get rid of this stuff that we don't need. I'm gonna save as a new name so I can. Oh, yeah, I'll save a copy. Um, anytime now, if you'd like to, do the thing, computer, great. Oh, same name. Whoops. Okay. So let's get rid of. How long does it take you to save this file? It can't be that big. Well, it is on a spinning disk. So we're going to just get rid of these state packet ones because we don't care. Um, okay. So this is the outbound write. This 00 is very interesting because according to my notes, that doesn't mean anything. Um, huh. Because as you can see, they have the sequence number that, but it doesn't. Okay. We're going to find some more A2 packets because this is weird. Okay, that's also 0, 0. Okay, here's... No, that's not what I expected either. Okay, 0 to 9, F3, that, space, that, by 1. Okay. I think my notes might be wrong here. That does happen sometimes. I'll have to review that. They might not be wrong. It might be something odd about. You know what? Let's find out. Let us determine what is supposed to happen. Yeah. Let's resolve this right now. So we're gonna go to see if my old program still works. Where's my Bluetooth dongle? Dongles. Okay, here is a dongle. Where do I plug it in? One of these tiny, tiny ports. And then nothing happens. Oh, there we go. Okay. Wait, what? Excuse me? Oh no, device not recognized. Um, that's my Bluetooth dongle. I kind of need it. Let's try a different port. Computer? I have to go borrow another Bluetooth dongle from somewhere else in the house. Okay, no, it worked in this port. That was weird. um, so I'm going to pair the controller because I don't think it's paired, and also my Windows likes to forget pairings. So I'm just going to add a Bluetooth device. I'm going to hold the share button on the PlayStation 5 controller and hit the power it on while holding it. And that's going to make it blink rapidly. And then I go to add Bluetooth device, wireless controller. And now it is connected to the computer. Okay. So I'm going to find my test program. Oh, wonderful. Thank you so much, Rewazd. I really needed you right now. By the way, Rewazd has support for the DualSense's trigger modes. They're all wrong. All of them. I know because after I saw them and found them hilarious, I sat there and figured out exactly how they set every single one of them and wrote code that does the exact same thing with comments all over it pointing out where stuff is stupid. Um, because that's very me. I'm sure you know. Uh, yeah, they did really stupid shit. So how do I get Rewaz to stop? I think I need to exit Rewaz. Oh, please close it. No, I asked you to close. Why not to close Rewaz to continue closing Rewaz? That doesn't make any sense. Okay. We're probably good. Back to my DS4 app. I'm finding my code, so once I have it running, I'll get this on here. Like I mentioned, I did actually get audio already working from wireless on the microphone of this. I'm just hoping that I missed something when I went through this data before, and already I'm a little confused by something, so maybe I did. I'm sorry for I'm not showing my desktop because I don't know what's going to pop up on my desktop, so I didn't share the desktop. I'm just sharing specific windows. That's why there's a lot of nothing happening right now. Because I've got putty windows open. I can't access my personal web space right now because some internet thing is broken. Yeah. Yeah. Well, no, I'm under that. I'm at 1175 at the moment. Um, let's see. Okay, so where is my DualSense tester? Ah, here it is. Laggy can set as default. Oh, my storage machine, my 198 terabyte machine is down to 3.12 terabytes left. It was actually at 2.5 or something, but I moved some stuff off. It's because my video verifier is so slow now after I had issues. Okay. Will this do what I needed? Only one way to find out, running it. Okay, I will add this to the share now. Add window capture. So what you're about to see is what it looks like when I am reverse engineering a controller interface. I apologize in advance for what you are about to see. Where'd it go? Ah, there it is. I present to you the absolute horror. This is the controller's data streaming into the computer. You can see this section here labeled BT only, that's Bluetooth only. If I was connected by USB, it would skip this part. I also gave it the offset of -1 because you can see I'm moving the joysticks now, and you can see the joystick values change. Now I'm left trigger, right trigger. You can see the left and right trigger are actually also present as digital values over here. How far do you have to press for that to count? It looks like anything other than 0 counts. We've got the various buttons. We've even got the touchpad data here. This section here is the touchpad data, which is interesting because this bit is a 1 when your finger's not on it, and it can track 2 fingers. Actually, tracking the finger locations. The battery temperature is currently positive 13. What does that mean? I don't know. Yeah. I don't think so. We were able to determine some things because I got some help with a few things. I had a person who was very cold out, so I gave them a program to run, and that they could literally reach out their window and put things on their roof. And they took their controller and put it on their roof while it was connected, and we just waited to see what the number would do. And when it got to 0, it then wrapped around and went negative, which is how I know that that number is signed. Now there's the same thing on the DualShock 4. What I think it clamped at 0 for me when I was testing, and then suddenly it started going negative at one point, which really weirded me out because I'd never gone negative before. But everybody mislabels this as battery power or percentage on the DualShock 4 because when they plug it in, it goes up. So it must be the battery power. But no, the battery power is actually over here. On. Yeah, the battery power is actually all the way over here. My cursor doesn't show for some reason. It's weird. Oh, now it's showing. Oh, it has to be in focus. Weird. But yeah, the battery is right here. It is only a value from 0 to 10. Interestingly, on the DualShock 4, when you plug it in, the number increases by 1 automatically. So unplugged, it's 0 to A because it's hex, and plugged in, it is 1 to B. That's a little odd. You can also see that I have charge and full. This bit here becomes 1 when it's full. This bit here is on when it's charging. I was able to test this. Even on my Bluetooth, I can plug it right now into a phone charger. And now that bit is 1 for charging. So it's currently charging by phone charger, which I think is a bad idea. So I'm going to stop doing that. Yeah, we have microphone and unknown here and a bunch of other things. We have if it's under USB power, if the headphones are plugged in, if there's a microphone detected, all sorts of weird little flags on this thing. Here's that CMAC I talked about that's changing. And there's the weird padding on Bluetooth here that's just all zeros. There's this weird value here, which appears to be an error code over Bluetooth. Like if something goes wrong with the Bluetooth, I think it's the count of Bluetooth packets that were bad, not parsable because the CRC didn't match. Then we have some more padding and then the CRC. And I think there might be other debug info in this padding, but I don't know because I don't have the firmware image to reverse. All of this work is by knowing about the DualShock 4, the PlayStation 4 controller, and then lots and lots and lots of trial and error. Yes, I'm serious. So this is a counter right here. There's other counters. There's motion timestamp, which I eventually figured out the units, and that's why it's in seconds now. Same for the device timestamp. Because here's the accelerometer and gyroscope data here. But we are here for a reason. And I almost forgot when explaining all that. That reason that we saw something I didn't think was correct. Saw this message here and several others. Scroll up, please. That had believe a packet going out in. Okay, this might not actually help hilariously. That's funny. I might have done all that for nothing because I just realized something. This is going out. This program's display of outbound stuff is limited. Now I can send messages to the controller when I press certain number keys when this program's in focus. It actually changes the values going out to the controller. We can see that the last message it sent the controller from the title bar. Oh, you don't have the title bar. Hold on. Okay. We can see the last message I sent from the title bar there is A2 31 02 000400. Oh yeah, we definitely got something here. This is definitely something. Okay, hold on. Definitively, this value here needs to be a 2 if you're writing out to the controller states for the LEDs or for the rumble motors or any of that. That needs to be a 2. Right there, that's highlighted. That's not a 2. Okay. So using this information, we are going to do a little bit of cleanup of our log here to remove junk we don't need. So we know that any A1 report followed by 3 and a number followed by a sequence number right there followed by a 1. Anything like this is going to be controller state data. So we can preemptively remove all of it. Sorry. And make this problem easier. So we're going to do another backup copy. The main way that I do all of this work is literally Notepad, just like this. Okay. I'll keep going and we'll see if anyone shows up. Knowing my luck, they won't. But who knows? Maybe just imagine if I figure out how to do the thing. And it's kind of sad because I was about to get to the craziest part of this interface that I knew. But if you gotta go, you gotta go. because there's a sub packet carrier of some kind here, and it's wild. See ya. Okay, so let's replace all confirmed controller state packets from the file. Okay, they are now gone. Well, let's see if we can label some of these other weird things. This log is getting a lot shorter now. Say that. Okay. So we have an O5 feature report here. O5 feature report is git calibration. This is what you normally have to call to make a PlayStation 4 controller start acting like a PlayStation 4 controller. For some reason, it really likes asking for the version date. That's strange. Could it not do that for a bit, please? Okay, let's see if there's any other A3s to find. F2, A3, F2. F2 is unknown, at least in my public documentation. As is F1. It is likely part of the USB pair, which means that I actually do know what it is. I do actually know about that stuff. I just don't really talk about it. Yeah, that's probably like, oh, yeah, you know what that is? Yeah, I know. I realize what that is. I'm sorry. It's not pairing because we're on Bluetooth. That was the handshake to validate that the controller was real. Yeah, yeah, that's what that was. I don't really bother much with that. I really should learn because then I can get some interesting little bits of information from the controller. But whatever. That's all those are. Um, okay. So now we know that all of the A3 packets are essentially useless. Um, so we're going to remove those after I save a copy of this. And then we're only going to have, I think, the A2 packets. And then I'm going to compare the count of packets to another file I have. And if the count is the same, I can just switch to the other file, which I've already done. And I technically didn't find anything. I wish I could make these reverse engineering streams interesting, but let's face it, they are one of the more boring things out there. Oh, my email. Why is my email? Nothing? Nothing from Discord. Nothing at all from Discord. Dicks. Okay. Well. Um. Since these are all useless, here's what I'm gonna. Teen. Okay, so start of line followed by 18 anythings, space A3, space star end of line new. Wrap around with hold. Oh, regular expression. Okay. Let's see how many we have here. 2541. Okay, what happens if I move duplicates? I still have more lines. So things are going to continue. Okay. So this is where shit gets really weird. Really, really weird. So I've done this already with another set of packets. I'm going to bring in that header. Okay. So I have seen the 9.7 packets before. We'll get rid of the leading space. It's not very happy with me doing that. That was a mistake. Okay. So I already know oh wow, okay, let's remove obviously duplicate lines that are right after each other. That's because of the man in the middle, so the thing got logged twice. Go. Okay. How many do we have? Two. Other file I have is but some of this matches my file exactly, actually. So I'm gonna see where it changes, because I could just copy and paste my old file over. Makes sense too. Oh no, I can't. Oh, I cannot. Interesting. Okay. So here's where things get very, very weird. I can copy some of these directly over, and I will. And it makes my life easy. Okay. So this is the first one. What's really weird about these packages or packets when you're in mode 0 here, 0, is that they have a sub-packet structure. These were those packets here. Add. Sub-packet here is 9.7. Da, 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 da. It's really strange because it seems to have like meaningful structure. See if I have it. My notes. Uh, okay, so trying to find where I might have a note. Okay, I guess I'll just wing it. 9-7 appears to be a packet type. OB is a length. So, oh yeah, fucked up arrow. Let me swap that switch with another. Of course, the reasons I'm having issues with my keyboard modified it so heavily that I can literally pull switches out of a Corsair K95 without opening puller. Right, switch puller. You were just here. I just used it. Ah, there it is. It turns invisible when it's at the right angle. Yeah, my right arrow key is not doing search. That should work better. Okay. So OB and then 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. It's the length. Subpacket structure is literally ID, length, data. There are some that seem to be double the length indicated. But yeah, that's it. That's the packet. I don't know why. But that's how it works. Are these identical? Yeah, there are identical ones. Let's just remove all duplicates. Yeah, now it's flowing better. Okay. 26 lines up with 26. Okay, I'll be able to copy that over. Here we have a double. Yep. More this I can blanket copy over from my other sheet, the better. Okay, so 1096. What does that say? Where do we desync? Is this synchronized? No. But we desync at some point. Try the last weird packet. Okay, 915 and oh wow, that's a very different number. Great, we're gonna have to do this the hard way. Wonderful. Or at least some of it the hard way. So first, these packets. Two, yep, they're long as expected. So here's a sub packet, and its length is 3F, which if not actually up to date on my hex lengths, I mean, I know I should just take OX40 and then that's 64 or something. Let's see, 40 is, yeah, it's 64, so it's 63 long, but because I'm doing characters, it's actually 2. So if this is 126 characters, and it is. So yeah, here's a sub packet. And then if we look, this one here, this byte contains that sub packet and also contains another sub packet of the 9.1 variety. So we have a 9.0, a 9.1, a 9.5. A lot of padding. So what's going on here? This is some sort of sub packet carrier where if you are in mode 0 on the report that you're writing to the controller instead of, I believe it's instead of mode 2, you're on mode 0, send command sequences. The command sequences appear to be marked with their type, their size, and then their data, and then the next command is present. I have no idea what these are. They might be some form of audio packet, except one of these turns the microphone on, which kind of goes against them being a microphone packet. Or not microphone, but the audio data packet. The media remote it uses the same command, so I'll look at my source code for that. Okay, so the media remote sends the packet command. It sends let's see, 9101. At least that's what I'm sending. And then 00 is mic and key off. Not 910101 is mic on. 910102 is key. This is for the media remote. For the I don't know how I figured this out, but this allows you to turn the buttons on the media remote and turn the microphone on the media. Unfortunately, I still don't know how you set the infrared codes for the 4 buttons that use it: the mute, power, volume up and down. But I do otherwise have that remote fully working, including sending audio over wireless. But 9101. Well, here we have 910102, which, as I already said, oh, did I have those backwards? That's weird. Let me check my source code from my DualSense. Uh, okay. Okay, interesting. For the DualSense, 2 is microphone on. So we know for a fact that subpacket 910102 turn mic on, and 910100 turn mic off. These are things that we know already, which is impressive. Or I guess I say we know, I know. And now anyone who somehow finds this stream also knows. Now there is another weird packet here. This packet. I have no idea what it does. 9102. OB1F. I have no idea. So I wish I had like an easy way to like just mass edit this file based on the number. But it's So let's see how many of these match. Because if I can keep pasting from my pre-prepared document until I find where they desync, that could help me a lot. Because that desync might be something I missed. Okay, so we've got 7 lines and 7 lines. That's good. Let's just go up to line 1, followed by 30. Okay, that match. Maybe I can use wind merge. Or hell, maybe I can just pair them directly. Hey, it's comparing. And it's confused. Okay. If we compare ignoring white space and setting swaps, that's what we more spaces. Okay, we're not detecting. It just failed horrifically. Oh, but they're side by side aligned, so that could help me find where the desync happened. Oh, there's a desync. Okay, maybe I could just add these missing ones to the old file. Maybe that'll work better. So we're synchronized most of the way. Still synced there, still synced there. Uh, that's not synced anymore. That isn't either. Okay. Yeah, I need to get bigger guns out. I'm gonna try wind. Because the fact that I'm missing packets is, and it might be where I missed the important piece of information for microphone data. I don't know. Fortunately, being only a minute long, I don't know if the person managed to get the audio sent to the controller, but if I'm lucky, they. Now, I don't think audio uses this sub-packet carrier thing, but maybe it does. That'd be weird. Okay. So, where is my WinRAR? Ah, yes, it's right by my DB. I'm kind of really hoping that WinMerge does this right so I don't have to go through hell. Okay, so we have test 5. Just test all hit. Doesn't even all hit any. Okay. So the options we set. Okay, I'll start changing. I know you can't see this. It's not very. Okay, so fortunately the comparison is mildly retarded. That's annoying. It does ignore spaces kind of, but if it sees a space versus or any number of spaces versus no spaces, it compares those different, which is a little perturbing. So based on this, I'll probably just have to re-edit file, same spec. That's annoying. Okay, I'm gonna pop. So I can kind of. Okay, so the good news is it's actually not that weird to do. Um, I kind of did it already. Do find anything regex replace. Start of line 1, 2. 0 to 9 F and spaces. Okay, so this matches all 9 ones. So now we put this in parentheses. Then we can put it back. And the 9 1. Now, when we go like this, hit right here on the 9 1. Then we replace, it does nothing. What we're going to do is we're going to add enough spaces, push the 9 1 over to there. Now, 1. Oh, you can't even see my regex. One of these that I replace will get pushed over to the correct location. Is it perfect? No, far from it. But it does a lot of the work. Let's see. I'll deal with some of the other. Okay, so we've got now these annoying hybrid ones here. Where we're going to fix that, going to find same thing basically, but it's going to be one of these 9 0 ones is in front of it. So we're going to say 0. It's 9 0, then 0 to 9 F repeated 128. This is not the correct way to do it. Actually, no, let's do it the correct way. 6. That's because it contains Okay, I want to replace that. $1, $2. If this works, it'll add a space, which it does. Add a few extra spaces. Okay. Now that packet structure looks pretty good. Everything looks to be... We've got another problem here. 9106 and then 1, 2 stops. That seems all right. Then we've got question mark 5. We've got these 8D. Oh, they're D5s. Okay. Let's just see if I can just move this whole thing. I wonder if this is the audio data. Because there's so much of it. Maybe it is the audio data. I mean, that would be fantastic. If I've been sitting on it the whole time and just didn't know. But I don't have high hopes because I'm going to guess that this is all padding. Yeah. Oh. Okay. Huh. You guys have no idea what shit's going. So this is where ridiculous regex tricks start. So this starts with a 9-2 here. I needed to get all the way over to star. So this is where stuff gets stupid. First, we are going to match anything that has a 0 to 9, A to F, or a space for 561 characters. Then we are going to match a D or a 9, followed by a 2. Let's test that. Okay. Work. Now we are going to add use this to put a space between. Actually, no, it doesn't need a space. It needs a lot of spaces. We'll do this one manually. But this is what it's like to try to solve these conundrums. Text. Let's line it up there. This is the number of okay. Now we have that midpoint there. Okay. Then we have these. Now they're all misaligned, but what's interesting about their misalignment is that I can fix it the same way. It's just 961 followed by that, and we're going to make one space. So find one. Okay. but I've lost it. There it is. Replace. Yep, it's working. That's all. This is a massive abuse of regex, by the way. Oh, something went wrong. Oh, I left it extra space at the end. That was a mistake. It still snuck its way in there. Weird. Okay, we're gonna put the space between them, put the space there. This way. Okay. So like I said, we're abusing the hell out of regex here to fix its data alignment and everything. Oh, and that one ended up. Oh. Let's see. I wonder if these are Opus frames. If these are Opus frames, I can figure out how to send wireless audio from this. If they're Opus frames. That is a big if. Let's see. Let's start doing this. If this is 9240 and see 40 is C4 8. That works. Does. And after that is a 0, which we're gonna, well, we don't need it. Then want to restore that 0, but we also want to put space in. These are such rude regex hacks. It's unbelievable. That didn't actually find. Oh, it did. Okay, it looks like it is working. Why is it only replacing one at a time? That's annoying. I don't know what's wrong with my pattern. That's disturbing. For some reason, I can't. Oh, wait, in selection. That was the problem. Okay. That's all the 9/4s. Now, the 9/2s are basically the 9. So that's all the 9/2s. Now, the D2s are basically the same, only they double the size. So that 8, 6, 5, 1, 2. See if I'm okay. The number of spaces it should need, I think. Doesn't seem right. D2, 40, and a bunch of stuff. How long are I'll get the calculator out. X40. Oh, times 2. Yeah, I'm doing that right. That's huh, that. Okay, let's try it now. Find. Put it in selection again. What does he keep? I goofed. Wow, an old goof. Very old goof. That's funny. Yeah, there's actually padding there, and I never noticed. That's funny. Okay. The final version of this is going to be quite crude and simple. Just going to be any sequence of bytes, spaces, that is 1,250 characters long from the beginning. Then, okay, followed by that are space or two zeros, and then there is a set of 0 to 9f of length 8. Line. Yep. Okay. So let's make sure these are in a capture group. Got it? Now the correct thing to do here, take $1, 0, 0, some number of spaces delta. Crude regex work. See if this works. I don't like the $1 at all. Yeah, that didn't work. Try escape. Escape one works. Okay, let's save and look. Oh, it's selection again. How does that keep getting turned on? What stupid thing am I doing? Okay, we're almost done, but we're not quite done yet. These paddings here are longer. Number of spaces to add. So much estimate. Number of bytes for characters before it is 1352. Won't worry about 0. Let's see how we did. We got stuck in selection again. Why does that keep happening? Okay. So now we have all of the packets meaningfully organized. It's a weird sub-packet structure, which I think might be some form of abused opus. um, which would be really cool if that's what it was, because if that is, I have so figured this out. And that would be really, really big if I figured this out. Okay. So, I should have a sample opus data. Editor. Oh no, those aren't. Okay. Every frame of audio data from the microphone looks like this. This is specifically a sequence number that is an entire byte, D3, and then the opus audio data. The D3 I think is part of the opus. How did I get this? Let's see. I gotta check my program code real quick for my microphone test. I'll look at the PS5 media. That's simpler to understand. Okay, so the report ID is 1 and the report data 1. That means mic audio. One, oh, wait, that's mic. And yada yada. Okay, so we got the Bluetooth sequence number. So we have the SQ followed by oh, that's got buttons and stuff. I use PCM. Okay, the report bytes skip 3, 7, 70, 7. Six. Hmm. We've got 90, 91, D or D5 or 95. The S gets doubled. Well, you have two. I'm skipping around too much. You have 90, 91, 5. Then we have 2, which is a little bit strange. That 2 5s come before 2. They do. 9-7 packet. We have padding, which I can just get rid of the padding. Who cares? I'm going to change file names now. We're going to get rid of the padding and the CRC portion because they're completely irrelevant with the data that we have now. But we've definitely got something odd here. I don't know why I didn't look into it. Call this test6.text. I call it text. No, I called it test. So it might be right back page work. Oh, all might be right back page. I butchered my OBS for this. Okay, so what I'm gonna do here, we are just gonna get rid of everything. Okay. So this is the new, actually, unfortunately, it's been so long since I did the microphone thing. I can't remember the exact structure. But what I'm probably looking at here is Opus with no audio on it. That's my guess. But there's also some sort of command carrier as well, which is what's so weird. Okay, looking at my code, if the report ID sound. That's the one thing that doesn't make sense is that sound data coming in from the mic is type 2. Hit input coming in is type 1. And these commands going out are type 0. And hit data going out, I believe, is type 2. So I don't know if this can be audio or not. I kind of discounted it being audio data, but it could be. That'd be really weird because it's a command sequence. But then again, maybe it's a command sequence that can contain audio. Um, so for the vote receive sequence comes in, followed by another sequence number, followed by some other piece of data, followed by care about. Do I have a sample of the raw microphone? question. This is pre-trimmed. I untrimmed. And no, I need the version. All these pictures and stuff I generated from it. I don't have the damn raw capture. It's really. Where did I put it? That's really annoying. Maybe I have some. Oh well, I'm just gonna have to run my program. Do I have mic capture? Wrong visual. I'm trying to find where my mic capture code. Run it real quick. Get a clean. Okay. So it's concatenating something. Skips 3, 7. Then it puts. Oh, wait a second. 26. Shifted left. It's D3. It's putting the D3 on. I had peeled it off. That byte 2, 3. That one. Okay. Okay. What am I looking at? What is this? This silent? Silent? It's too big to be control data. Especially when we get to these. D5. Oh, fuck. Oh. Hmm. Um, I don't know yet. I don't know. Um, Opus audio code. So the microphone data comes in as the Bluetooth sequence number, which is X2, because part of it's counting in the twos. But there's just X1. I forget. It's 2. Yeah, it's 2. So X2, where X is the sequence number and 2 is saying that we have audio data. After that is second sequence number, which is an interesting choice. Audio sequence number. A. Then we normally have 3 data. Let's see, that's 209. 9. Oh, it's 210. 70. 70 bytes of data with these bytes in front. Okay, that is microphone data from the media room. I believe the D3 is actually part of the microphone data. The SS is the audio sequence number is odd. So that means I need the documentation. I need the Opus specification, the codec itself. Okay, we're going to get this on the screen somehow. Where did I put? Okay. Oh, I've been really goofy. Oh, that's stupid. Uh, out of my copy. Clone. Let's see. Oh, now the other scenes are. Oh, good lord. Everything's all topsy. Copy. Sure, cat plate. There we go. Everything. It. I accidentally cat plate scene. Oh, I can undo that. Okay. So delete the content. Yes, remove items. Okay. Now things are looking how they should. Um, as I was saying, we are going to look at something. We are going to look at this. No. Why is that still? What is that? That's not even the. That is my YouTube download script. Why is that there? Way. I had to double check these before I display them. Okay, this one's fine. I grabbed another terminal window that had the same name. So the RFC specification. RFC, RCF, RFC, RFC. These are the specifications for the Opus audio codec. I hope this is what I'm looking for. Okay, yes it is. Okay, perfect. So D3, which is what the microphone data comes in as, actually means let's see. Okay, so the D is actually 26 in decimal shifted over 3. So 26 we can see right here, smack dab in the middle of the Celt data. Specifically, it is the 10 millisecond frame of Celt. Now, what does the other part mean? Okay, this table is very important. There's an audio frame. Let's see. Because all of this information is the big. This information is something else. Save this file. So for D3, that is configuration 26. With a subparameter of 2, or of 3, rather. It was D2, wasn't it? I wasn't saying. Oh, it was D3. Oh, this is code where I was messing with. That's why this code. I was replacing the D3 with the D2 to see how the code I would decode. Oh, I don't even need my awful thing. We got a better one here from the RFC. Got this one. Which also shows I was this is numbered backwards. Because this is the high sig bit here. This is the low sig bit. So this, I'm pretty sure this is rendered backwards. Yeah, the top 5 bits. So these are the wrong way around. That annoys me. Least significant is index 0 for obvious reasons. Okay. You can't. Oh, you can just barely see it. Oh, I'll just turn. So we can see that when I was seeing D3, I was seeing configuration 26, which is 10 millisecond frames, and I was seeing D3 would be both of these bits true. Just C. Damn button. C, line C. Okay, the one additional bit labeled S signals mono or stereo. Okay, so S is mono or stereo, and C is the number of frames per packet, 0 to 3. I'm just going to copy these. So D3 means that it is a type 26 with an arbitrary number of packets. So, oh shit. Oh my god, has this been under my nose the entire fucking time? How did I forget this? D5 means 26 10 millisecond sections. 5 is going to be stereo and arbitrary. No, that doesn't. Something's not right here. I need to. Am I reading this byte backward? Or do they really go from high? No, top 5 bits of the talk byte are configured. Yeah, the top 5. When you say top, you mean the most significant. So a D5 would mean the same D. Okay, 5. Put that in a calculator. It's better to be absolutely. Okay, so D5. That's stereo, but it's not arbitrary length now. It's 2 frames in the packet, each with equal compressed size. Now when we see D5, it's followed by a length C8. How long this is. Wait, can't remember if D types were the split. Okay, that's where things are weird. D5 is stereo, but C5 is also stereo. The D5 is double the length here. So the 5 is saying stereo, but it's also if it's an Opus frame, or not Opus frame, but an Opus config byte or talk byte, it's saying 2 frames in the packet, each with equal compressed size, and it's stereo. But then why is it sometimes a 9? What does 9 mean? Okay. So if we take a 9, x9, it's actually 9, 0, shift it to the left 3, hit. No, I shouldn't, should I do, I shouldn't do, I'm going to do the actual thing. 9, 5, shift it to the left 3. It should eliminate the 5. And, yep, okay, we're still, it's 18. 18 is narrow band, but also 10. Holy shit. How the fuck did I miss this? This 9.5 is narrowband 10 milliseconds. This stereo. This D5 is that's super wideband at 10 milliseconds. They're both at 10 milliseconds. But hold on, what about the command that turns the microphone on? What is that? What is that actual command? They're abusing something on Opus here. They're like they've written a fake command in Opus, if I'm right about this. So let's just see. So 9.1 it's going to be oh, it's just someone crazy with me. There are some modes where it puts a length after, which is why I'm really interested. So I said 9 was, I think 9, I said 9 was 12, but let's shift it again. Oh, it helps if I put it in hex mode. Yeah, that's hex 12, which is 8, which is the 10 millisecond and narrowband. Go Celt though, they seem to love Celt. So they're saying it's mono. It's narrowband, Celt, mono with 2 frames. I gotta step away. That's wonderful. My text is gone. Like, fuck. Oh, there we go. Will my browser page load? Probably not. Refresh. Oh, it loaded. Yay! I'll be back. Of course. Yeah. Uh, Cough button is better if you're, muting yourself with it, unmuting yourself with it. I've either just cracked this completely or made a stupid, and I'm not sure which one it is. So, gonna look a little bit more at the RFC because the one thing that we're not sure of, it appears that these are config bytes because they're consistent with what I already know about how the DualSense sends microphone data. The thing that's weird about them is that this is the microphone enable here. I don't know what these are, but they're probably too short to be audio data. But I don't know. What's weird is that they doubled the length of the data that they're sending versus the length parameter. Like, I don't think in Opus the second byte is length, but then again, there was some mode where it was, I think. So that's what I have to figure out. Right away, what do we got here? The, let's first think about the D5 and 9.5. They're in mode 5, which means stereo. Um, that's stereo, but this is 1. 2 frames in the packet, each with equal compressed size. Okay, that's the case. Frame packing. Oh. In type 1, the length is written in bytes. Okay, what about type 3? Type 3 is an arbitrary. I think I just figured out how to send audio wirelessly to the DualSense. I think I just got it. I think it's... Nine five. So it's this one. Pressed frame. N minus 1. That's not what I'm seeing. Kind of. Not They're clearly doing something Opus-ish. Code 1 packets, the talk byte, immediately followed by the n minus 1 divided by 2 bytes of complete. But that's not what we're seeing. Not at all what we're seeing. I don't know if this is valid opus. We see the config byte, but then we get the length after. Now the reason that this is here's an example. Length after. Now what we've got going on here is in this case, they just happen to know the frame size. So they my code is it not sending pure opus? No, they were sending pressed. This is very confusing. So in this case, they know the length of the packet. So that's uh, n is the number of bytes in the packet. So when they subtract 1 to remove this byte from consideration, left with this, and they divide by 2 because there's 2 frames. Um, this is the mode that I think we in, except we have a length here, right here. And I don't know why we have a length here. That's what's weird to me. But let's check the other codes. Maybe they did something weird. Code 2 packets for code 1, but let's act like we're 2. Clock byte is followed by 1 or 2 byte sequence, the length of the first frame. This is what I feel like we're looking at. But this is not the opus. This is not correct. We're dealing with a type 1, 0, 1, not a type 1, 0. But this fits the bill. Okay, what does D3 do? D3 was what I was seeing in the original raw data. Talk byte is followed by a byte encoding the number of frames in the packet. Bits 2, 7, marked M in the bit 1 indicating whether or not the opus padding is inserted. The raw mic. something's. So the mic data came in with the sequence E3, which according to my code right here, although I don't know if this was the final code, I decoded it not as D3, but as D0, stereo. Obviously not right. Let me see what my dual. Okay, it's the PCM target. Okay. This one I'm pretty sure it worked. So let's see. Did I do anything weird here? No, I didn't. I used the D3 as provided. So maybe I just use them as given? But why is it so? Because D3 means that the next byte had had its length, number of frames, but it didn't. Here, look at this. D3. That means that one F here. Okay, wait, that doesn't change it. You have to be above C. Okay. Level one. Yeah, that doesn't make sense. I have the raw opus. I have to see if I. Something's not quite right. That's what's bothering me. Is that something isn't right. But maybe the specification I'm reading is out of date, or maybe I'm not understanding. Okay, set as startup. DualSense audio test. Start up the wireless DualSense. Will it connect? Okay. It's not connected. Okay. Low on power? Okay, I guess I haven't given it the updated firmware. I think fix some charge issue. Yes. So see what this program does before I run it. Oh, it just shits out a PC file. It does nothing to it. It just makes the file. Okay, let's try it. Um, testing, testing, 1, 2, 3. Okay, here's the files. See any? No, I never checked if. Okay, so the hex editor. Oh, wow, really? Uh, so I made it dump a hex thing apparently. Here's the bike data. It is D3. And the PCM version of this. Classic. Options. Playback on. Ah, god damn it. Bug just flew in my eye. That's a fun problem you have using computers. Right. Let's see. Here's fly. Okay. Let's see what this sounds like. Cannot render file. Oh, because it's a PCM. It's a raw PCM file. Wait, how do I make a PCM into a proper wave? I forget. Get. Um. Damn. I can't just play a raw PCM. Really? Okay. Damn it. Did I leave myself a note on how to fix this? Um. Okay. I've got a. I've got a PCM file, and I don't remember how to play it. Um. I have an old version of Audacity. That worked. I have to run this through FFM or wrap it in a way. This is a little perturbing. Big demonstration to make sure my code works for Mike still. Okay. Can this open the Okay, oh, file, import, raw data. Oh, that's probably what I did. I mean, PCM and Wave are very similar. Wave just puts like a riff wrapper around it. Okay. So I saved it as save it. Okay. All is okay. 48. The sample rate is 480. Single channel mono, and um, actually say signed. Obviously, we were wrong. Very wrong. Oh, why is it in 32-bit float mode? That's obvious. Try that again. Knowing I didn't keep. Okay, God, the raw import is slow. Oh my God. Okay. What did we save? CM target is just a binary writers. Question is, how's our decoder set up? 48 one channels. What PCM did I save? What did it decode as? What am I doing? What have I gotten wrong? What have I gotten? I used an Opus decoder on. Should have made. Why? Now I've gotten this right before, so what did I do wrong? Eight kilohertz. I can't remember what the right settings are, so I'm just gonna have to like try stuff. Okay, that's obviously that would kill my ears if they played that. Do 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 do. Or a little. Try unsigned. Oh, that is terrible. I I had this issue before when I was first. Can't remember what was. I mean, it looks close. It's clearly audio. I just can't remember what the settings are. And I decoded it to PCM, but you can tell it's working in the. It's definitely signed. Try 8. Okay, that's not it. So what am I doing wrong? I saved the PCM fragments. It's all good, but how do I make a wave out of it? That I can't remember. And I did it, and I didn't keep a note in the folder for some reason. The heck was I thinking? Actually, wait, there is a wave file in this folder. Maybe I can check its properties. That wave, I saw it. Oh, oh, that's terrifying. If I play that, we're all dead. Okay, that's interesting. That's very interesting. Did I have to mangle the data? Make it work? I wonder. I wonder. Okay, so I also had the PS5 Meteor, and I think that's where my success files are. But I also got it to work with 500. That's a little. Yeah, I don't see any successful waves in this. That's weird. That's really strange. I know I've had this work before because I have one of my old polls. Let me go find it. Let me check the settings on. This is an older one that I did with the media remote. Worked fine.
Testing, testing. 1, 2, 3.
So what are the properties of this file? Thanks for telling me almost nothing. Property dialog. Okay. Properties of this file. It is a wave of ECM Little Indian signed 48 kilohertz. Huh. Yet when I try to open the raw data, the duration. Okay, let's make a few changes in our theories. First, was it one channel or two? That's probably one. Signed. The other one was signed. Yeah. So why does this come out like ass? It's so close, but something isn't right. What isn't right? What if change? Oh, wait a second. This has the code that's perverting the data on it. God damn it. Uh, I left the test code in it. That was the mistake. Testing, testing, 1, 2, 3. Oh, now it's the corrupt stream. That's interesting. Why? Why does it think it's corrupt now? Things are suddenly getting interesting. Okay, what if it's work, testing, testing, corrupted end of stream. Okay. stereo. Testing, no, and corrupted. Testing, no, corrupted again. Thing is, I know this worked at some. Test. Still, oh, buffer too small. Okay. Oh, I goofed the code there. No, I didn't. I'm just buffer too small. What am I doing wrong with this audio? It doesn't matter that you can't see the settings I'm poking around with. They're just decoded. When I receive audio frames, put them in the. This is aggravating because I know I've had it work before. So what changed? Something's gone awry somewhere. This is aggravating because I had it work. I bet my note is like in a Discord thing somewhere. I gotta find it. Ah, fuck. I'm banned for that right now for bullshit. And they still haven't gotten back to me on my ticket, and it's driving me insane because they're probably just gonna delete my whole account. Oh, I'm so fucking angry. Why is this not working? What am I doing wrong? Here's the data I'm looking at. Those should be Opus frames, and yet it doesn't like them. Why? I'm not sure D3 is the correct mode. Hmm. So the code from the remote, which I can't find the remote, I would try it. The code on the remote is currently configured. Send to write it, force it as stereo, which obviously doesn't. I'm so aggravated because it was working. No, I had this work. because I have my test audio. I record. Decoder, check if I have the same. What have I done wrong? $70. Let's see, is 70. Let's see. Okay, so this is getting the control. Okay, 77. We lose 4 to the CRC32. 71 to the, actually, this doesn't include 70. For skip 8, or 1 is the sequence, 72. One is the other sequence, 71. 71. Okay, so that's right. I was going to end up getting, I figured some shit out, but why is this not working? I thought I would have like an opus fragment somewhere where that it worked, but I can't find one. So I'm just kind of stuck here. Figure out what I'm doing. I'm obviously close. When I use the data exactly as presented, I record that. What's interesting? Oh, no, corruption. Error occurred decoding because there's no way it's type D3. No way, because it's all wrong for D3. It's acting more like, let's see. It's acting much more like D0. 1 frame. Yeah, it's acting like D0. So if we force it to D0, that's not D0. Let's see. 6 shifted. Yep, that's D0. So if I record this from the blue, and now I'm recording, and the program isn't freaking out, it's not dumping errors, it's actually recording audio. This suggests that everything should be hunky-dory. Now I import that audio. Like that successfully encoded into a PCM stream without a problem. So I grab the PCM, I open it, Oh, and I picked the wrong option, so I didn't choose for raw. Raw data. Okay. Grab the PCM stream, load it in. We'll just get the hertz run. Huh. It's clearly trying, like it's close. It's clearly very close. Because if everything's wrong, you just go. And it also decoded correctly, which makes me think I'm screwing up my loading of the PCM somehow. I doubt that it's a case of mono versus stereo, but I'll try it. That'd be funny if that was it. Okay, 2 channel stereo. That's not it. So what's the problem? Okay. It aggravates because I know I've done this before. And I can't figure out what's wrong. Something is just not right. And I don't know if my issue is in the P or if I'm setting wrong. What have I left to try? Let's see. I doubt it's 4 channel. I'll just make it by way too. Plus it's a like signed likely. Signed 8. Obviously not. Okay, I'm gonna import it as 30. I'm sure that's gonna be. Actually, what if I try this? Oh, that'll be. Basically, it's kind of hard to decode to load the PCM data in wrong because if you get it wrong, you generally just look at a sound wave that looks horrifying. Get the endian order wrong or anything. Just looks terrifying. So if you make the depth too, if you make the number of bytes too large, or the bit size too large, then generally you don't have a wraparound problem, so it doesn't like screech at you. This file. It's so close. I can't remember what I'm doing wrong. Really aggravating. And it's probably in like a fucking info dump where I was sharing it with someone on Discord. I can't read it. Because Discord has been banned for bullshit. Because I apparently had like, well, they told me I did all these horrible things, like personally posted these horrible things. I never did. And then like you figure out through other people who didn't get banned that a server disappeared, that you had powers in, like I had powers in the server and didn't know it, and that's what happened. The server I don't even like. I talk to people on, but only when I'm added. So I had no idea. And it's just like Jesus Christ. Okay, so we know it's 10 millisecond sections. That's right. Everything should be working. I don't understand why it's not working. I don't know what I'm fucking up. Really annoying. See what the decoder thing. Test. Okay. It thinks that the channel count is 1. Sample rate is 3800. I think it's set at. Oh wait, is that the prop? No, that's not the. The weird thing is we're not like with the default settings, we're breaking the encoder, the decoder. It breaks. Which makes you think, oh well, maybe one of these comments that changes the default settings fixes it. What if I just have the wrong default settings for the decoder? What if coder what if I just take one of these samples and I oh so I had one of these print out as text this data. They all do actually. I just take this, I replace, I get rid of all the dashes, I just forever that. I wish I had access to my damn programming notes on the Discord. Okay, I found an old comment. Turned out the Opus config byte was valid, but I needed to use USB PCAP to make sure I got every packet, and those still was strange. So, the problem is that my method of reading the controller is too passive. That's it. The audio data is actually fine. This whole time, my confusion, everything, it's because my program cannot generate clean. It doesn't pull the thing enough. So there's no weird encoding or anything. That explains why my program was finished incomplete. Like it had weird comments and stuff, and it's because I was trying to fix it and then I figured the other thing out, which didn't involve the program, which is why. Okay, so knowing that, then these are, if this data is valid framing, that's why it sounded right, by the way, is because it was missing so many packets, but the parts that I did have decoded properly. Son of a bitch. I realized that I downloaded my entire controller disk, which this is probably going to die without me. Like the data will just, if I downloaded it, so my bot was in it still, so I had the bot token still valid. But we've confirmed stuff. Okay, let's start trying to take some of these packets apart using what we know. Let's just do that because I'm gonna tie myself up knots if I try to go too far with it. So 90 that it is. It's always 10 to be 10. The 9, the 90 shifted to the right by on hex mode. 90 shifted to the right by 3. Okay, that was weird. It's 12, which is in decimal 18, which is there, which is 10 millisecond Celt only narrow bandwidth. We are a one frame packet. But then, for some weird reason, these have a length in them. 3F. I don't, I don't understand. Is this a valid opus? I don't think so. Okay, 90. This is optional padding. Okay. So 90 means that we are type 0. That's this type here, which means one compressed frame, which is the number of bytes in the packet minus. Okay. But then why do we have a length right away? That looks kind of like a CRC. Find out. CRC. Oh, well, these all end in DFs, which means they can't be not CRC. They can't, because the entropy would be too high. They couldn't all be the same. So those aren't that. Huh. I probably need to rethink power control. I need sense of well, audio in, audio out. Know how that. What if? Oh no, that. What if I just send the microphone data back to it? Put that on the list of options. Okay, so that was loud. Running out of ideas at the moment. Because what's weird is the size being on every packet. It's like they're abusing the system. Send this data, whatever the hell it is. Not clear what it is, but they send a length. And what's really weird is that when it's the higher um, bandwidth, it's twice the length. I don't think that's how that works. Let's check the RFC. Okay, so if we have a super wide bandwidth versus a narrow band, both on Celt. Are we on Celt right? I'm trying to figure out what the frame size is. Let's see. Oh, it's source code. Celt. Jump into the Celtic. Okay. Modified discrete. Yada yada. Um, so if we are a first, let's check this. This is 60. Then, but I get 40. Oh, I forgot to divide by two character count. Okay. So want two, two frames. 92 seconds. But NB appears of super C. Hmm. Yeah, proving out that is actually. The thing that's screwing me up is that like, how does a command that appears to be an opus frame start the microphone? Doesn't make. They're all sent as Celt and Opus, or they're all sent as Opus Celt frames, every single one of them. But then these weird ones have the size, for some reason, as the second value. But they all do, all of them. So with this one, this D5 versus the 9.5. Now what's interesting about the D5 is that it's um, super wide bandwidth if that's parsing correctly, whereas this one narrow band. But why is this frame? Why are there two frames that are the same type of? And that's also how it encodes. Wait, I think that's how it's silent. This is really confusing. I can't tell what on earth it. Now we can see something rather interesting here. These are ascending, whatever these are. Although it seems that they just loop around whatever they are. Oh, that's interesting. Around all of a sudden. So my first thought is that they're abusing the Opus codec in some way. It's not consistent with that. Like, yeah, these are pretty much smack dab for 10 millisecond Opus frames. They're perfect for that, all of them, if they were Opus frames. Okay, let's assume they are Opus frames. They're all Celt. Celt 10 milliseconds. Some of them are narrow and some of them are super wide. If that's the case. Ugh. Then what activates the? Why does this activate the microphone? And on the remote control, it also this sequence here. Change this 2 to a 1, it activates the key. Why does it activate the microphone with the key? Why does this do? But I have learned something. I have confirmed. Oh, I should uncover that. I have confirmed that these are opus frames of some description. I'm a little bit confused as to why they include their own sizes. I don't think Celt does that. Like, I really don't think Celt does that. But I do kind of wonder if I put all of these packets into a file, will I get oh, there's something to try. That's silly. That's really silly. I gotta try that. So if these are all if these are in fact valid opus data, Then padding is gone, the CRCs are gone, everything is gone. I replace these bars with space. Forgot about that. I had wrap off. Wrap turn. Okay, if I take all of this and I put it into a hex editor, I should now have an Opus file. Now, if I save this file out, let's see. Now let's just fucking wing it. Have some. So, if I just save all of this data as Opus, will it work? I don't even know how to decode that though. The rate would be missing, so it shouldn't work. Oh, but if I manually craft an Opus header, okay, hold on. If I put an Opus header on it, this should not play. Correct, not playable. That's what I thought. Okay. Opus files are a thing. I think they're probably super slim. Like what I need is a header to go in front of the raw Opus to just tell it about it. Kind of like how PCM files don't like they need a riff wave header. So Opus file header. Okay. Oh wait, there's an RFC for Opus file format RFC. So the file format for Opus should be some amount of marking around the around at the beginning to tell it what you're dealing with, and then just the Opus codec data. Okay, that's the Opus codec, Opus file format specification. Let's see what that says. Now, I do know that a certain command turns the mic on, which is really freaking weird. So figuring out what that is in Opus might be weird. Maybe it's like some sort of special null byte they're repurposing. I don't know. That's really weird. They're abusing it that way. Okay. So an Opus stream is organized into an ID header, a comment header, and then the data packet page. Okay. That's in 5.1. Got it. Is placed alone without any other packet data. First page of the logical that page. Okay. And beginning of. Wait a second. Can the pages be different sizes? All subsequent pages of audio data page log packets contain are audio data packets. Each audio packet contains one opus packet for each of n different streams, where n is typically one for multi-channel. Range each one of these. One. One in this one. Oh, it's a 9.7. That seems a bit excessive, a 9.7. You'll end up with 12. Or oh yeah, so okay, so all right, duh, stupid. 7 is the first three that yeah. Okay. So how do I make this opus stream Yeah, I'm not gonna try to figure that out. Because the thing is like a opus stream at the header. What I'm gonna do instead is I'm just gonna fire all of these opus packets something. How do I do that though? How many packets are ever in? How does that activate them? So weird. Unless no, that wouldn't. Let's say the microphone is always on when when there's audio coming out, but it's like well, maybe it like starts the audio subsystem. They're really odd. Something, something's. So, the question is, are these all valid Opus frames or not? That's the real question. Because if they are, then I can just start jamming them all into an Opus thing and coder, decoder, whatever you want to call it, and it should decode. So I don't know though, because one of these turns the microphone on and off. As another special value that for the media remote turns the buttons on and off, which is really freaking weird. So I do. Let's get this into calc real Excel. Call it. I just want to see what it looks like when I import it as fixed, and then I see what fields have the tag move. Okay, so you are a fixed width file. Stop. How it needs here. That one. Okay, I think that should text. Okay, a few types. See what I'm. Oh, wow, that's a lot of data to copy. Okay, it's done. The dynamic. Okay. That. So X decimal XOR. I'm using calc to try some stuff. Uh, XOR bit X with, let's see, 1, 4. Why would that? Okay, so put a 4. Oh, I want it to be. So we are going to see. Modify this formula. Let's bit XOR why is it not like it should just be 4? Oh, not XOR. That's dumb. I want bit and being fucking stupid. I hate when I do. Okay, so basically what these say is whether or not the number or not it's stereo. There are some that are stereo. Okay, if that is equal to 4, then 2 else 1. Okay, abort. I made a boot. Okay, we gotta wait for leap effect on. Oh, that work. Shit. Ah, crap, another couple together. Now they're entangled because I had to paste one to the other. Source was frozen. Okay, I will get ice cream. It's too late for ice cream. Um, okay. So back to fish. I had to mute randomly because I coughed hurt. Oil is not good for microphone. So what's happening here is I had a strange thought. I thought, wait a second. What if the number of channels always adds up to that are active always adds up to the same? Now I don't think that's going to be the case, but You test these things. Yeah, it's not going to be the case. You can tell already looking at this, but you say if this, then this, else 0, like that. That creates the filtered version. Right there. Hmm. Let's see what happens. Hmm. That's weird. You know, the command that was used to turn the microphone on, then does some other stuff, and then does this ascending thing. Kind of weird. The odd 9-7 only exists up here. Not very long. The Obis thing only did like, let's see, what's the mic use? $71 bytes, 70 bytes of data. That is around 47 inches. Hmm. Some of these are big enough. Some of these are definitely big enough to be holding data. So this doesn't seem very logical. It's got 5s in here. Probably not true. There's probably a flawed path of research. But something that is interesting is to look at the relative sizes. For some reason, this one over here becomes this weird command stream that runs forever. Very strange. Fonts, please. Oh, for fuck's sake. Probably trying to preview the font. I have a couple theories. No. Yeah, it made it angry. Come on, unfreeze. I'm kind of thinking of just jamming every single one of these in sequence into a Opus decoder. Let's try that. What we're going to do is we're going to replace any number of spaces. Okay, the new line. Oh yeah, we'll give it a header. Since regex is by default greedy, should yep, there we are. Okay, now we just need to deal with a little bit of extraneous. I could probably stream to multiple platforms. Oh, restream one. Oh, that's interesting. Those three are the same. Oh, let me get this because Libra Calc is gonna crash now. Go away. Crash already. Um, so here's the Okay. This is the sequence of commands sent to the controller over Opus, I think. I have absolutely no idea how to make this work. So we're going to get a little bit creative. First, we're going to replace 0 through 9F every 2 bytes, followed by bytes with first pair, comma, OX. What I'm going to do is literally stream all of these into an Opus encoder or decoder and see um, if they all are compatible. I don't expect them to be, but you never know. But I had to convert them into C sharp. Some of these definitely look like they could be Opus audio though, doing the silent piece. It sure is taking its time, isn't it? Oh, my whole computer. It's lovely. Yeah, it's doing a fit. Your Chrome's probably a thing. Gotta have some juice. Program. Come. Yeah, it's locked up. Still waiting. Come on. The problem with the Opus decoding anyway is that I don't know test. Like they're probably all gonna fit because they might need different rules. No. Yeah, I think I just stuck. Well, I mean, it's doing something. So what I'm trying to figure out is if these are valid Opus frames or not, because they certainly look like Opus frames. But something's not right. Come on, unfreeze Notepad++. You're just doing. Oh wow. Even the encoding's going tanking. I'm at 20% loss because of this. Yeah, my encoder's in the toilet. It's still frozen. So I need to figure out how to even tell if these are real. These frames don't make sense. That's the short of it. They don't make sense. I don't understand. They don't look like valid Opus. But the coder needs to even know what to do with them. Like what it's um, the decoder needs to know the bit depth, the byte destination, byte size, and all that other stuff. But instead, it's it unfroze, and it only did a fraction of what it was supposed to. Oh, good God! Oh, probably actually did half of it. It froze for that long, and it did half of it. It might just close on me now. Never know. Can't see it interact with it still. Lovely. Now, let's see if there's any documentation on sending control signal opus frames. Embedded opus control signal. Really just Googling at this point. The first problem I have is I'm not sure how to pad these frames out properly. Like looking at the RFC somewhere. Lost it. I've lost it in my encoder is crying. Is this even watchable anymore? I don't know. I give up for now. But the short version was that I think I figured out something. It might all be Opus all the way down. Um, if that's the case, then I might be able to send audio to a controller already. But I need to do some investigation on Opus multi or Opus quad track and stuff. Oh, I can't actually press the stop button in OBS because my mouse input's wonked. Ah, jeez. Uh, my mouse inputs are just being eaten. Okay, where are they going? Okay, now I can stop it. Oh, but now I can also find that my program's actually not frozen at all. Something else is just chewing all my resources. That's lovely. So, I don't quite get the. Let's see. Oh no, it's just gonna keep doing it again and again. Yeah, that was a failure. Regex is hard sometimes. Yeah, this Opus codec just the data doesn't really make sense. Oh, well, my FPS is randomly going to 12. I'm gonna end this stream, but I am gonna say that I've made some pretty progress. Not sure how useful it's gonna be. Basics determining that this is Opus style data. Since that's the case, it's possible that this is that I just need to push Opus audio directly into this interface, and it might just start coming out of the controller. I don't know. I'd prefer to understand these control signals or whatever they are. The way they could be Opus silence, Helt based Opus silence, but I'm not sure. So I'll find out.